This is a video about solving a problem, about designing something useful, and about figuring out what tools are needed to go from plastic to metal. But first we need to talk about this basket that I bought for my e-bike. It comes in handy, but it's large enough that I don't like having it attached if I'm not using it. Taking it off and on doesn't require any tools, but because of how it mounts, you need to completely take apart the quick release mechanisms instead of just flipping the levers. This isn't a deal breaker, but it can be a little awkward, and I think that we can do better. My idea is this: a custom bracket that uses the existing mounting holes on the bike and has slots that the quick release bolts can slide into. The slots are shaped so that the top bolt slides straight in, and then the basket pivots down until the bottom bolt drops into place. Then, the quick release mechanisms can be used to clamp down on the basket and prevent it from slipping. It's a simple design that we can quickly model in CAD and print in plastic, and while it's good enough to confirm that the geometry works, it's clear that we'll need to make a stronger version in metal. Now, if you spend as much time watching maker content as I do, then you'll already know about PCBWay and all the fabrication services that they offer. I can honestly say I was already planning on using them for this project, so I was pretty excited when they offered to help out with this video by providing some parts for free. Their two services I was interested in were CNC machining and metal 3D printing. This is my first time using PCBWay, but their website made quoting and ordering parts quick and easy. So big thanks to PCBWay for their help. Now back to the video. So there are two manufacturing techniques that we're going to use: CNC machining and metal 3D printing. These two processes have very different strengths and weaknesses, so it's important to make two separate designs. Also, even though I'm not paying for these parts, I want to optimize for cost. The first design we'll talk about is the one intended to be CNC machined. When it comes to CNC machining, it's important to avoid unnecessary complexity. Every extra feature can mean more machining time, additional tool changes, or even multiple setups, all of which increase cost. For example, I got these two designs quoted, and removing the chamfers lowered the price from $80 to $66, saving $14 or about 18%. Ultimately, I decided the chamfers were worth the extra $14, but it was still a useful reminder that small design choices can have a real impact on cost. I was also curious to see how order quantity affected price, so I got a quote for 50 pieces, and the unit cost dropped from $80 to $34, saving me $46 per unit, or around 57%. This highlights how much cost is due to initial setup time, and that we can make this part considerably cheaper simply by ordering more of them. Now let's move on to the design that we're going to be 3D printing in metal. When 3D printing in metal, the geometry can get very complex without adding much cost. What matters much more here is how much material we end up using. Because of this, 3D printing in metal goes hand in hand with something else that I've been wanting to try out: generative design. This is my first time trying generative design, so I'm definitely not an expert, but the workflow goes something like this. You tell the software, put material here, don't put any here, and these are what the forces are going to be. Then, once all those constraints are defined, the software runs simulations and figures out a geometry that's both strong and lightweight. The result is typically a design that looks more like it was grown organically than designed by hand. Now, a design like this would be tough to machine, but when it comes to 3D printing, sacrificing simplicity in order to reduce material is the exact trade-off we're looking for. So after printing this in plastic and checking that it fits, I returned to PCBWay, where I found that it would only cost $71 to get this printed in stainless steel. So for a single bracket, a 3D printed stainless steel one comes out to be cheaper than the CNC'd aluminum one. However, when I increased the quantity to 50, the unit price only drops to $60, making CNC machining a more economical option at scale. I also got a quote for what it would cost to take the CNC design but get it 3D printed in metal, and all that extra material causes the price to nearly triple to $208. So if you're planning on getting something 3D printed in metal, definitely make sure you're not using more material than needed. So now I have two bike brackets that solve the same problem, but were made in very different ways. If I were developing this into a real product, I'd do more FEA simulation and testing to get a better idea of strength and performance, but for now, they seem to work pretty well. The bigger point here is that designing useful things isn't about knowing how to use one tool. It's about knowing what tools exist, what each one is good at, and how they can fit together into a workflow. My FDM printer didn't make the final brackets, but it helped make them possible. If I had jumped straight into ordering the metal parts only to find there was a mistake in the design, that mistake would have set me back by at least 2 full weeks. Instead, I was able to catch those issues with a plastic prototype that only took a couple hours to print. So if you have a 3D printer at home, or you're thinking about getting one, I'd encourage you to see it as a part of a larger workflow, not as a silver bullet for manufacturing. A 3D printer is an amazing tool, but it doesn't have to define the limits of what you're allowed to make. Because like I said in my last video, plastic is great for some things, but not for everything. Thanks again to PCBWay for your help, and thank you for watching.